Okay, guys, good afternoon. Go and pick up maybe 4 or 5 scripts together in a zipped file from Blackboard under joins and subqueries. Okay, so under weekly learning, you will find class scripts, is it? And then you'll find joins and subqueries .zip file. So starting today, we will work on joins and subqueries, and you have to understand, of course, what they are before we can work on it. And I'm marking your in class for myself, so we won't waste time in class for that, okay? Because it just had more to work on instead of just. Okay, so once you open it, we'll start working with the My Contacts job. So once you have it, they should come, I don't know, maybe 4 or 5 files together is what I gave you. So this is summer, and okay, so you should definitely see 1, 2, 3, 4 files in there, right? So we'll start working. So we'll work slowly and steadily for the next 4 weeks on joins and subqueries. Now, what are joins and what are subqueries, and how is it different or difficult from what we've been doing till now is this. Till date, we've been working with one table in the database, right? We've done all our selects, updates, deletes, alter table statements only with a table. Now that you have CRUD under your thumb, you can create, you can read, you can update, and you can delete. We've done one small part of database management, right? Very small part, in the sense we now know how to create databases, hopefully how to write our comments a little better, how to create tables, best fit types, their sizes, different types, and select, update, and delete statements, okay? Now the next step is that every database will definitely have more than one table. One table is, you'll hardly ever see a table in a database. Why? Because whenever you write applications for organizations, any organizations, there will be more than one entities involved. Look at Georgian College itself. Like we have student entity, students exist here. We have professors or teachers entity, we exist here. We have non-teaching staff. Then we have staff at the high level, in the sense of president and deans and so on, that are not basically teaching staff, but then they're there. And of course, then we have all our services in the college, and we have to keep information about all these services also, right? Whether it be computers, you use your own computers, but we have computer labs and so on. So when you start coding or when you start creating databases for an organization or database for an organization, right? Any application, you will notice that it will always work with more than one related tables, right? So if it was Georgian College, I wouldn't be keeping information about cars in a table in the Georgian College database. Doesn't make sense. Okay, it will be more for a car dealership. So when you have tables in a database, they will almost always be correlated, in the sense they will have some relation with each other. A simple relation between students and teachers could be which teacher is teaching which student. A very simple one, right? Or what all teachers are teaching a particular student. There is also a relationship between you and programs at the college. Which program are you taking, or programs you are taking? Similarly, between you and courses, between program and courses. So there are relationships that exist between tables when you have more than one tables in a database. Which means that now if I have relationships and I want to extract data from more than one tables, I should know how to join these tables, and just not join them randomly. There should be some kind of relationship between the two which helps me join the tables. So there are joining randomly where you just can say, take this table, let everybody from this table, let every record talk to every record in this table, and it's called a Cartesian product, right? So everybody talks to everybody kind of. But more practically thinking about it, there will be some kind of joining condition that will be involved. So maybe if you and if I have to match your course number, the course you are taking should be a course I'm teaching. Then that will tell me that, oh, you are my student, right? Something like that. So there will always be some kind of joining condition or conditions that I have to look for. Also, when more than one tables exist, we have also to take care of a very important issue in databases, which is duplication of data. I don't want to duplicate data at many places. I don't want to keep student data in 10 different tables. So when I create tables, I have to more think of about design. Till now, you've only done one designing aspect, that every table has to be in the first normal form. That is, it has a primary key, and that every field is atomic in nature. That means it doesn't have data of repetitive type, right? So now when you start working in more than one table, you will see that more restrictions or more design issues come into existence. Maybe there is, so I have a name, like instructors have a name and they have an ID, and my employee ID is also saved in the HR table, right? So the human resources will also have my information. So instead of keeping my information in a table about teachers, all my personal information should go into the HR table. And then there can be an ID that matches that HR table with my table, in which I'm keeping information about the courses I'm teaching and so on. That's not my personal information, that's the courses I'm teaching and so on, right? So you'll see that even fields will be related and there will be restrictions on the field. For example, I am an employee of Georgian College if my ID exists in that table. So in the HR table, if there is an ID 4 and there is no teacher with 4, that means something is going wrong. So not only selecting data from different tables, but updating also. So if I have to update the information of personal information of Anju has to be changed for whatever reason, then she must exist in that table, and then maybe updating it there also affects other tables, right? The whole concept of selection, updating, deleting kind of becomes big. When it becomes big, it will definitely be more complex, right? So complexity means that you're using the same concepts. You are doing selections, you're doing updates, you're doing deletes, but you have to be more aware of relationships that exist in a table. How is it related to another table, and so on. So it becomes very difficult to picture it all in your head because all you see is code. So what Workbench allows you to do is that Workbench will allow you to kind of create a diagram, which is called an ERD, Entity Relationship Diagram, that will help you, oh, this entity is related to the other entity. So there is a relationship. What are they related to? Maybe a field, maybe more than one field. Maybe that field is a primary key in your table, but it is a secondary key or a foreign key as it is called in another table. So starting today, it's complex, but it's doable. So I'll go slow and steady, and instead of doing subqueries separately and joins separately, I'll kind of do both of them together. They are both sides of the same coin. You can answer a query using joins. You can or may be able to answer, or sometimes not, answer the same query using a subquery, a query inside a query. Okay. Now you will have to read up a little as to which is more efficient. And again, it's just reading work. And in the real world, you have to think about it, because maybe join is taking a minute and the subquery is taking 10 seconds. So definitely you have to see which is more efficient, right? Having said that, so as I said, we'll have to just go slow and steady. So I've given you 4 files for now. I'm hoping I can finish them in 3 weeks, right? And then there are some extra labs that I'll give you when you're ready for it. Now, during this term of 3 or 4 weeks, we have 5 weeks still to go. I'll assign you an assignment somewhere in the middle, maybe after a couple of weeks. Maybe next week after class is finished, I'll assign you your final assignment, which is basically on joins and subqueries. You may have done everything, you may not have done it, but at least you can start doing it, and then I'll give you time to kind of finish it once you've practiced a lot with it. As I do joins and subqueries, I'll also be talking about design issues, of which you've done 1, the first normal form. But there are 2 more that still need to be at least done. There are many more, but 2 more that I would like to do with you, which is called the second normal form and the third normal form. Again, remember, if you do not design a database or a table well, you're doomed, right? Because once you start populating it with data, you've started working with it, it's very difficult to update it. So before a database is created and tables are created and it is populated, a whole design team, which are called developers, They sit down to say, okay, this field, this is the table name, these are the attributes that should go into it. Here is the type. We should keep extra space for if required, and so on. What values will go into it? Should I use what type? Best fit and everything. So all those have to be decided before the database is in action. That means before you actually populate it and start working. So there are design principles. You have first normal form, you have second normal form, you have third. For your information, there is also fourth and fifth, and there is also a BCNF, Boy Scout normal form. All these are rules that if imposed properly on your tables or followed, will result in good table design, right? So of course, designing is not in your course, it's more of programming, but I would at least introduce you to the three normal forms. So one is the minimum. No table must exist without one, right? It's the minimum. But as you work with more tables, second and third automatically kick in. I mean, they will. Then you have to take care of those also. So no redundant data, no duplication of data, because remember, duplication is always bad. Duplication means if I make a change at one place and the data is duplicated or replicated, I'll have to ensure that that change is shown in all places, right? And database is not something that you can say, oh, I'll close down everything, I'll update everything, and then reopen the table for use. Think of it. Everything works 24/7 these days. The bank cannot say that ATM, you can't go to an ATM or to a bank machine and say, oh, it's sleeping now, it's doing something with its data. It cannot. So you can't change things. It's not easy to change things in the long run. So we always start right so that we know what we are doing, right? So again, I will not emphasize a lot on designing, but I would definitely, as a programmer, you should know why are we creating this table as we are creating it. Don't take my word for it, oh, this is the best table. If you remember, there was a table we worked on last week or a week after that, before that, I can't remember, which had a manager ID and employee ID. And I said, it's not a well-made table just because the manager has to be an employee, but there was nothing done in that table. We'll learn how to do that now. Last week, we saw a grade book in which each student record was occurring more than once because a student takes more than one courses. Not the best of the design. Why? The name of the student, the ID of the student. That was the only two fields, but maybe the email of the student, the program of the student, all that data will be repeated many a times. So you have to learn how to split information so that information is kept at a place, unless, of course, duplication is required. In some cases it is, but it is kept at one place, and there is a joining table between the information and some other information that needs to be related. So you should, if time permits, I don't know, I have no clue whether we'll have time. You should also learn how to take a big table and split it into different tables so that all the tables at the end are in third normal form. So I've not been able to do it with my other classes because it is a big job in the sense that it's time consuming. But let's see, because I have 5 weeks, you never know. You may have the chance of doing it. So we'll start with, there are a few scripts here you will notice. So we'll start with I'll start with the easy, not the easy ones. I mean, a basic one today in which I'm doing the least work. And then I'll kind of go on to do all my scripts one by one. They're definitely not going to finish today. It will take a couple of weeks for sure. And then while I do it, I'll also explain you how to work with it in Workbench. So open up the scripts called My Contacts Jobs. I'll start with that one because that has some basic things and then we can forget about it. So I'll pick up there's a jobs and there is a jobs too, right? So I'm talking about jobs first. What am I looking at? Summer 2018. Okay, there it is. And weeks 9 to 13. So I'll pick up the jobs 2 one, the Blackboard one that you have. I'll pick that up. I'll open it and I'll save it in your. It's only jobs. There was no 1 and 2. So jobs is the one that I'm opening. So jobs, not the jobs 2, just the jobs one. Just the jobs one, yes. So let me save it at the right place so that I can find it when I find it. So this is Wednesday today. You know what? I'll just make a week 9 folder. No, I'll just do this. Never do. So we are sitting in week 9. Most of you should know it, but leaving the last week, I mean, the last week will be again the exam week. We have 9, 10, 11, 12, 13. So I have 5 weeks. So I'm kind of comfortable that we should be okay with it, just because it's what it is. Uh-oh. So did I pick up the wrong file? Yeah, I picked up the wrong file. So jobs, just the jobs. Okay, let me save that as. And again, what I'm talking about today is only related to MySQL. I'll say this is available in MySQL or not. And then, of course, if you're working on some other in the long run, when you go out for a job, keep in mind there could be something extra. For example, in alter table, we only have first and after, but Oracle gives you before and it also gives you positions. But you only stick to what is available in the database. They're almost the same, but there will be some minor differences. Okay, so let's start with this one. So we'll create a table and some tables now therein, populate them with data and extract information from the table. So this information, as far as I can remember, is about jobs. So there is information about people looking for jobs. There is information about what job they currently do. There's information about what job they really want to do. And then there is information about what jobs are out there in the market, right? So it's a database that is keeping information. There are 4 tables in the database, and 1 is about contacts, people looking for jobs. 2, the jobs they are doing right now. 3, the jobs they actually want to do or desire, or maybe people don't have jobs, and that's the 3rd table also showing people who don't have jobs and desire jobs. And 4th, which is not related to these 3 tables, but it's a listing of jobs out there in the market. Okay. So I am doing a job, I want to change my job, I look up if there is a job listing for it. I can put my request in the job desired one that I'm looking for this job, so on and so forth. Right? So that's what the whole database is about. So there are 4 tables in it. We'll go through each one of them one by one and kind of talk about them. The first one is setting up an environment for me. Again, we may not require it again on our machine at all, but notice how I have a statement which says set default storage engine to InnoDB. There are 8 to 9 or maybe even 10. So there are a few storage engines in MySQL, and they work differently in the matter of some allow foreign keys, some do not enforce foreign keys. Some do a locking of a table when somebody is working on a table. Some only lock a row and not the whole table. So they are different in their properties, and of course, if their properties are different, their efficiency and their outputs are different, right? The 2 common storage engines that are used out there are ISAM, and the InnoDB, right? Why have I chosen to go InnoDB is because I'm going to use foreign keys which are not supported by ISAM. So I do not know. Of course, I know what's on my machine. I know that on my machine, the default is InnoDB, but it's just safe because we do not know in which server environment we'll be working. I want you to keep in this habit of writing your set statements or setting up the environment yourself so that you're not dependent. And you cannot say to the database, guy there, oh, can you change it for me? No, he won't. So everybody works on their own scripts. And if you require a certain kind of engine to work with, this is what you work with. So if you kind of Google the default, these are called storage engines, okay? If you kind of Google storage engines in MySQL, they're almost the same. Some may provide more, some may provide less. I think there are 9 or 10 in MySQL. So here you can read about MySQL supported storage engines here, or if there is one that, in the reference manual also you will see alternative ones. So they'll talk about storage engines here and the setting of how do you set it. You can set it for a table if you like, which I can show you. You can set it for a table if you like, or you can set it for the whole script for all the tables. So sometimes you may want one table to behave differently from another table. All you do is you add an engine you put engine equal to whatever you like at the end of the table description. If you remember, I showed it to you when we took a table structure in one of these scripts. So here, if you notice, there is my ISAM, there is InnoDB. I see a CSV for comma separated one. I don't know what memory is. And then if you like, you can read a little more about what they are and what do they contain and so on. So overview, and then each one of them is kind of listed here. So you see there are a few here. So because my ISAM and InnoDB are the most common ones, I kind of read a little about them, and I would tell you to also kind of read a little about them. So there are two options. You can set it for the whole script by going like this, right? You can just do it like this. Or if you like, different storage engines can be done for every table. So I could add an engine here and give it a value here for this table. I could do it for another table. And so it depends, right, how you want to work with it. Now, I chose just this because it was working for my script and I'm fine with it. That's what I want, that every table must have a InnoDB storage. So highly recommended. Give it a half-hour reading. Just read it. I know you won't understand everything. I didn't understand everything too. I don't work in the database real world that I know everything about everything, but I do understand a few things, maybe a little better, maybe a little worse than some of yours. Read it, give it a reading. If you're totally confused, forget about it, right? If you are confused about something and would like to ask me, and if I know of it, I'll tell you. But it's something that is not as if it's something it's in the brain that you know each and everything about an engine. Whenever you do something, you kind of look up and say what will work best for me. And fortunately, there are only two, InnoDB and my ISAM, which are very popular. The rest, as I said, I haven't even read about them. So you usually have to make a choice between the two. And InnoDB to me looks more, it's more recent also than my ISAM, and it has more features also. So definitely for our joining and subqueries, our tables, we will go with InnoDB. I'll show you a place where it doesn't work if I try my ISAM. The rest of the three statements, hopefully all of you are familiar. We are dropping it, we are creating one, and we are using it. I still keep the drop table, though it's useless because when you drop unless asked in an assignment, it's not useless then it has a mark. But otherwise, it's useless for us because when we are dropping the database, it automatically gets dropped. Now let's look at the tables. We all know our tables. So you can argue with me or you can give your comments as we go on. The contact ID is an int. It's unsigned auto increment primary key. So I needed a primary key for contacts. People are applying for jobs, any contacts, right? So I couldn't think, they're not students or teachers that have something that is a student ID, but I need to have some primary key in my table. That's rule number one, right? Normal form one. So I created an auto increment one. I went int. I could have gone small int. Unsigned, though auto increment, if you don't touch it, starts with 1 automatically, but I still went unsigned so that nobody could change it to anything else, to a negative value. The last name, the first name are 30 and 20. You can change it to 40 and 40 if you like, 30, 30. It's not a big deal. They're just rough figures, but don't go 100 and 100, right? The phone number is character 13. Now I've used not an int, but a character, and that also a character, not a varchar, assuming, of course, that this is a database that is prevalent here in Canada. So our phone numbers are 10. 2 for the brackets for area codes are sometimes kept in 2, and then dashes are put between the 3. Now again, who will decide how phone numbers are done? This is not you. You will be told how they are being taken from the user, right? So the user is filling up this information on a form, most probably, and there is where you do your error checking. Oh, phone number has to be given in this format, and these days the format is already pasted. All you have to do is fill it in, so you don't go wrong, right? Similarly for date, you don't fill in dates now. You'll get a date calendar, a date thing comes up. You choose a date from there, and you cannot go wrong. That was not how it was a few years back, maybe 2 decades back. So now more improvement is done on the front end so that input is validated there, so that you don't have garbage in your tables, because GIGO, garbage in will give you garbage out. So assuming that, yes, I was told that the phone number is going to come in this format, I went with character 30, right? And why I don't want to go with varchar, it is coming in that format, I will stick to that format. And I don't take it to be a number because 1, numbers are more complicated than text, right? And 2, I don't want to do any math with numbers. Phone numbers, you don't do any math. You could be extracting data from it, which is so useful for strings, right? I could be saying, get me the area code. So all people living in Barrie and, neighborhood 705. People living at Markham 905, Toronto 416. So that is more useful. So why go with an integer in which I'll have to write an algorithm to extract the first 3 digits when I can do it with strings? So though numbers appear as numbers, fields appear as numbers, always think student ID. I would never go with an integer. Doesn't make sense. Why? Because like I know they're numbers for you guys, but it's an ID. ID could have anything. Employee number could have an E. Tomorrow, Georgian College changes its mind. It puts S in front of it to differentiate between students and employees. So never go with numbers, especially for IDs and for phone numbers. Okay. Then comes email. Now, this email, again, assuming is coming from the front end, has been validated. Otherwise, garbage will go in your table. I've given it a varchar of 50. You could have gone a little less, but again, it's a varchar because they're all strings, right? And just for your information, since you're programmers, I'm not sure where or if you will do it. You will maybe even in Java. Regular expressions are written at the front end. You use regular expressions to validate your data. So what is a regular expression? For example, for an email, it will be checked that there should be a at in it, and there should be a dot and some com or c or whatever at the end of it. So all that validation, I'm assuming it will be done before the data is saved in a database. But input validation is a big issue and a big job also, because if the data is wrong, you can't expect anything to be right out of it. The gender, I've stuck to 1, character 1, because I'll be saving M and or F in it.
So for the gender, when we set it to M or N?
So here I've used gender, you see it's either M or F. So therefore I've gone with character 1.
Yeah, but weren't that allowed?
Oh yes, oh yeah, I see what you mean. You are saying, can we go with enumerated data type?
Yeah.
Perfect, yeah. You should definitely a better definition. We should go with enumerated data type. Good point. And we are allowing M and F in any form. So we can go M, comma F. And that way, I think we can give it, no, we don't want a default value. No, we are good with this. Right, so M and F would be better. That will, when you enter the data in the database, you're just trying to add another layer of, checking. So I'm assuming it comes right from there. M or F is coming from my input. But while you are entering data, if it is a manual enter, it's not coming from an input. At least this saves you that nothing else but M or F go into this. And since you've done enumerated, definitely it makes sense to make it enumerated. The not null was just added for the heck of it. It's not, I didn't think anything about it. I just said not null. I mean, birthday, you necessarily may not have it, but sometimes when you apply for jobs, age limits, there is an age, you should be above this age or whatever. So I've made it not null. Phone, I kind of left out, though it's an important field, because like if you have to contact the person, one is email and the other is phone. So if you like, you can add not null to it. So the null and the not nulls were just done randomly. So I'll kind of go symmetrical. It makes sense that I have the phone number of my contact if I have to contact it. Some people don't prefer to give it. Therefore, then what do you do? Like either you give it a default value of all zeros. If I say not null, then I cannot put a null value into it, right? Some people just don't prefer to. And the zip says, what will zip help me? Where do you live, right? So zip is being used to see your, where do you live? So that if a job comes out in Toronto and you live in Barrie, are you ready to move or commute or whatever to Barrie? So that is where the zip is helping, okay? So every field that is coming here has a use. So that, I mean, you don't put, and then there is no limit. You will say, oh, I can put more things about this contact. You could, but we're trying to keep it at the minimum and the required for that particular application. So you need names, you need emails, you need phone numbers, the gender, the birth date, so that you can find out the age. And it is more enough zip to see if you, where do you live?
It's no big deal, but the zips in Canada
are 6. Yeah, you'll see that the data I have is all from US. That's why it is 5. This database is based on US, so therefore it's 5, right? That's the reason. Our zips are 6. So this data is coming from, and I didn't want to change it. I was too lazy to change it, right? I could have added whatever. And if you kind of look at them, they're not very, like, I'm not even sure whether they exist, like 1, 2, 3, 4, 5. But if you want to change it, go ahead. It was something I copied, so I didn't bother to change it. Therefore, the zip is 5 here, right? Again, if you want to keep it not null, you could go with it. Phone, you can argue, oh, no, some people don't want to give their phone number, which is not very like common, but whatever, right? So there's no rule here. I just copied it. I just got the data from somewhere and enumerated. I didn't notice, but I definitely make changes. I make my contact ID as unsigned. I just thought it would be better. And enumerated is a good change because it makes sense. And the rest I kind of just left as it was. Okay. And then comes the insert into, which is something that nobody likes to do, but again, some data was given, it's just inserted. So that's my contacts table. Let's look at the second table now. The second table is called the job current table. And in the job current table, it's informing you who is working where, kind of, right? So look at it. I have a contact ID here. I could have called it anything, but I've called it contact ID here. What title are you working for? Are you a system manager? Are you a DBA? Are you a professor? So that's your title. And then, of course, I'm assuming like every organization has different titles, but titles will give me some idea. Like, are you a computer programmer? Are you a chef? Are you a baker? Things like that. So it's a title, which I kind of think will help like whoever is creating this database with, oh, that's what they do. A salary, which is saying, I'm currently working at this salary, because if you're trying to change jobs, you wouldn't like to go less than what you're earning usually, right? And then the start date. So it's telling you, it's giving you some idea about contacts who already have a current job. Now let's look at the first field, which I have chosen to call contact ID just for the heck of it, because it makes sense, because contact ID means this is the person. I don't have his name or his email or anything here. Why? Because I can pull all that information from the other. So I'm not going to repeat information about this, but see lines number 67 to 69, which are important now. Here is where I'm making the relationship. I'm saying, of this, basically, this 67 is not important, but I'm giving it a name. I'm creating a rule. Constant means a rule. I'm creating a rule, and the rule is called table my contacts contact ID FK1. So basically, this is a kind of a convention that the rule name, the constraint name, will tell you which table are you referring to. So I'm referring to table my contacts, and I'm picking up contact ID from there. And FK stands for foreign key. And I'll define a foreign key in a minute. And I'm saying that this contact ID is a foreign key, and it is referencing its value from the other table's contact ID. Normally, if you speak it in English, this is what it is saying. Any person's information in job current has to be referring to a person in the my contacts. That person has to be in my contacts. Otherwise, why would I keep information about ABC if he's not even in my database? Okay. So for foreign key, now let's define what a foreign key is. You know what a primary key is. It is that unique field or field combination that determines or uniquely identifies every record. What is a foreign key? A foreign key is a field that draws its value from another table, right? A column of another table. So I could have more than one foreign keys in a table, but for every foreign key, this column is extracting or drawing its value from another table, and 99% cases in that other table, that field will be a primary key. It will be unique. I'm not saying 100%. Sometimes it's just a relationship. Oh, this value must be present there. And that is not a primary key there. It could be unique, but not necessarily a primary key. But most cases, it is a primary key. So 67 is just giving a name to this rule. You say why? Because when you start programming more and you want to change this constraint, you can just do it by the help of an alternate. If you do not give it a name, then there is no way of changing it, right? So it's given a name. So the name and the convention of naming is that you name the table to which this field is related. So the table was called table my contacts, and the field to which it was related was called contact ID. And FK1 just stands for foreign key, right? This is important. This is important. The name is important because every name must make sense. Don't call it ABC. FK1, yes, but then you will remember what FK1 is. This is important. You are saying that this field called contact ID can have any name. I'm just short of names. And two, it makes joins and subqueries easier. I'm saying that the contact ID field in this table is referencing its values from the contact ID of the table my contacts. So there is the relationship. And it's a relationship that InnoDB will implement. What I mean is this. If in this table I try to add a record whose contact ID is not in the table my contacts, it will go. It will say, oops, what are you doing? That's an incorrect record, and I'll show you. Okay? So that's the minimum information I need to keep. Anytime I need to know who this person is, what his email is, what's his phone number, where does he live, I can join the two tables, job current and the other one. I'll join them on contact ID. That's how they're related. And I'll find out that information. So I'm not duplicating that information. I don't want to duplicate that information. Okay. And then I have other fields, the title, the salary, and the start date. Now, this field is a single, and you'll say, oh, but there is no primary key. There is a primary key. It's just a normal int primary key. It's not a auto increment primary key because its value has to be drawn from the other table. So it's int, it matches that int. It has to be an int. It was unsigned there, it is unsigned here because I'm drawing it from a pool and it is a primary key.
So what happens if you get the contact ID?
It's how there is a table already that has some values. Right. This must draw its value from here. If you make it auto increment, they're not even related now. It has its own auto increment 1, 2, 3, 4. It has its own. Nowhere are you say like now I can add something here and it will automatically go 15, 16, 18, whatever. There's no restriction there. I'm trying to form a relationship, and this is how I form a relationship. I'm saying that this contact ID is drawing its value from that contact ID. So it makes no sense to make it auto increment because it's dependent upon something else, right? It's not independent. It is dependent, and that dependency is in line 68 and 69. Then I add a few records to it, right? So I've added a few records, but I've left, you can, if you like, for 7 and 10. So not everybody is employed right now. 7 is unemployed. You could add him. You could say 7 and you could give this special value unemployed and just null because he has no salary, he has no hiring date or whatever. 10 is a student. I just said student here and I'm saying the student is not employed. But again, this was just to show you if you don't want to, you don't have to put records. But notice something. I have only used these numbers. They don't have to be in sequence. It's just easy that they're in sequence. You can add wherever. I cannot add 19 in it. I cannot do it. It will give me an error. Why? Because 19 is not a valid value. Or could be. Let's see how many do we have here. No, it's not. There are only 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that means keys are going from 1 to 10. Is 19 even present in that table? No. So how can you do it? Because you're saying I'm going to refer to it. So I'm going to run it without it first and show it to you and then run it with it. Right? So if I run till here, table my contacts already exists. Now from where is that existing is the biggest thing now. Okay, let's see at which line. Create table my contacts. Didn't I drop my database? Even if there was one, yes, I dropped it. I created it, I used it. That is strange. That is really strange. Error dropping database. Oh, that's, things are not going right, seems. Why am I having errors dropping to it? Okay. Okay, so I'll do this. Just because I had hibernated or something, I don't think it is the reason, because it's giving me an error or even dropping my database. So I can't even go further. I can't even do this. Why am I getting, can't remove that directory? Why would that be? Okay, so I know where they are. I could do that, but just to kind of, it says I cannot remove that directory. Keep in mind, remember, all databases are being saved in a directory. So somehow it's not able to remove it. I don't know why, but anyway, it's not a big job. There is no existing by this name. Okay, we are good here now. Something to do with my system, nothing to do with you. Okay, now let's try it. Hopefully we'll be okay. So where were we here? So I'm trying to create two tables and put data into it. And everything looks fine, right? Now let me try to do something that is wrong. Let me try to change this person from 9 to 19. And I have a foreign key constraint, okay? I should get an error. There. It says I cannot add or update a child row. What is this child row? The dependent table. That's the child row. It's a child, right? Why? Because it is not present in the element. So if you bring your mouse over it, it will tell you cannot update or add a child row or foreign key constraint fails. It has failed, right? You're saying that the contact ID in this table must draw its value from the other table. There is no 19 there. So it says a constraint has failed, and it tells you which constraint has failed. Right? So that way, at least it's easier now. If you have names, it is easier. If you call it FK1, then you have 10 tables. FK1, FK2, FK3 is what you call your constraint. It's kind of difficult to find. So here is your error, which makes sense. Makes sense what a foreign key is now. So foreign key draws its value from another table, and it will do it because there is some kind of relationship. It just doesn't draw it for the heck of it. There is a relationship. It is telling me that this person is working with on this title with this salary and his start date was this. I could put more information. Which company is he working for example? That would be a relevant information to where is he working, right? But again, as I said, I got the data. I didn't make changes to it except look at the type. So I said title looks okay, salary looks okay. I made it unsigned, it wasn't unsigned, and the date is fine. Okay, so table 2 is understood. Let's look at the third table now. The third table is called job desired. Now people sometimes work where they don't want to be, or people who don't have a job, like student at student 10 and somebody 7 didn't have a job. So people do desire jobs. So there is a table here which says, okay, let me know what job do you desire. Okay, so what does job desire do? It again has a contact ID. It is not compulsory to have the same name to make it a foreign key. The rule makes it a foreign key. So you could call it contact ID 2, 3, 4, whatever you like, and still say that it is referring to the contact ID of the table. What happens by giving it the same name is some statements when you start doing join, if they have the same name, they're just easier to write in the sense they're shorter to write. If it confuses you, change them, please. It's not a rule to have it the same name. The rule is here. I mean, and on the other hand, just giving it the same name doesn't mean it is a foreign key. You say, oh, I'll remove this. They have the same name. There's no relationship having the same name. Okay, the rule has to be present. So this person is saying that this is my contact ID. Again, it's int unsigned. It is the primary key. This is the title I'm at right now. Maybe I'm not working at all. So I didn't say not null. Okay. This is my salary low, the lowest I can go, but this is actually my expectation. I'm expecting this to be my salary. And this is the title I want to go to. I want to be a chef. I want to be a baker. I want to be a computer programmer. And I have this much number of experience in this job that I'm looking for. So here is information from people who may or may not have a job. You have no clue. But this is a job they are looking for. So I'm looking to be a DBA programmer. I'm okay with the salary low of 100K per year, but my expectation is I should get 150. And then I have a few 10 years experience. So that's information on people looking for jobs. Do they have a previous job? I'm not interested. Doesn't matter. Or do they don't have a job? We don't know. You can always find it out. You can take this table of job desired, combine it with job current and see, oh, you already have a job. You know what I mean? So it can be done. But this information is telling who is looking for what job and what are their expectation in terms of salary. And what are their years of experience. And there is a foreign key again in this table. This foreign key is called contact ID. So this field is a foreign key which is drawing its value or referencing value again from the other table. Why would I keep information about Mr. X if he's not even in my database? because I'll never be able to send him an email or phone him saying, oh, there is a job for a computer programmer. Right? So again, look at how I've called my constraint. The line 97 can be totally removed and it will still work. But again, giving names means you can program them afterwards. Okay? So it's called table my contact ID because that's the table name and the field you are referring to. And I called it FK2 because I already have an FK1. But the important thing is which field is a foreign key, contact ID is a foreign key, and what is it referencing? It is referencing the other table's contact. No relationship of the same names. This is the relationship. Make sense? Okay. Let's look at anything that we can change. Years of experience, tiny int is okay. 255 years of experience is okay. It is an unsigned one, default 0. So if you don't have anything, that's 0. Salary low, salary high, unsigned, and not null. This is what my expectations are, 8.2 and 8.2. You could go 9.2 or whatever, but I just went 8.2. Varcat 30, this is the title I'm looking for. 30 could be a little small. You can go for 40. Here are 5 people who are looking for jobs. I mean, not looking for, they want a job change or looking for jobs. So 7 wants to be a computer programmer. He was that person who didn't have a job. He's okay with 80,000, but that's his salary high. 8 is looking for a job. Maybe he's already earning something, so that's his lower limit. I won't go below this, but that's what I'm expecting, right? So sometimes jobs come out when you will in the long run. When you look for jobs, you will say, oh, I'm looking for 120. But you say, it's only 90 is available. Are you okay with it? You say, okay, my lower limit is 90, but my expectation is 100. So if it's lower than 90, don't even call me, right? That's what salary low is. 10 wants to be a baker, 4 wants to be a sales manager, God knows what he's right now or she's right now, and 9 wants to be a chef. So people are doing jobs but want a different job. People don't have a job and are looking for jobs. So that's the job desired table. Same thing will happen if I try to add a key here that is not in my main table. And notice there is no, I didn't put them in any order here. So they don't have to be put in any order. It's 7, 8, 4, 10, 9. The first table was by default 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, but there is no restriction at all. Again, it won't be an auto increment field. Its value is being drawn. So its properties must match. That's an int and unsigned. This should be an int and unsigned. You can make it a character here because you're drawing its value from an integer field. And here are some records for that table. And lastly, though this table is not related to any of the other tables, but it is a table that is required in the database, is a job listings table. So it's an independent table. It is a table which has a job ID. It is in the first normal form, has a primary key. And actually by default, all these tables that you see are in second and third normal form also, but we'll talk about it when we come. When there is a single key, I mean the key is only single. Every field, there's only one key. It's not a composite field. Then it is automatically in the second normal form because the second normal form works with a composite key, right? And there is no composite key in my table. All my tables have single fields, one field. So these are also in the second normal form. I'll come to the definition and then we'll talk about it. So the job listing says this job is available. This is the title of your job. That's the salary that your job is, and it is available in this place at the zip. So that again, if people prefer, like if you go for your co-ops and you prefer to be in Berry, then it will help to say, oh, I'm here. I don't want to relocate. I want to stay where I am. So zip is telling you where the job is available, right? So those are the 4 fields not related to any table. I don't see a foreign key rule. Nothing. It's just a normal table. It is in the first normal form, has a primary key. Automatic doesn't make sense to have job IDs by anything else. So this is a good table. This is a good database where auto increment primary keys are natural, right? I can't find anything else for them. Title, salary, and zip are just giving you information. There is nothing else more that you require for a job posting. I mean, of course, qualifications and so on are different things, but in terms of who is looking and what is looking, this is enough. And then there is some data here. So there is a job for a baker, there is a job for a clown, a dog trainer, hairdresser, a jeweler, lawyer, so on, and all these are in the job listing. Neurosurgeon, artist, salesman. So somebody was looking for a baker. So you could say, oh, are you looking for a baker? You can combine the job desired table, pick up the job listings table, and you can look at the title and say, oh, you're looking for this title. There is one in the listing, and we can match it. But they're not related anyway. I mean, I cannot say, oh, the title here must come from that field, or I cannot say the title there must come from this one. I could be looking to be a DBA and I don't see it. So there is no constraint between the two tables, but I could always match. Oh, is there somebody looking? Somebody is looking for a chef. Is there a chef title? But otherwise, there is no constraint or a rule or no relationship. You will create the relationship. You'll say, I'm looking for a clown. I want to be a clown. Do you have a clown position? I want to be a DBA. Do you have a DBA position? So it's an independent table sitting in the database, but a useful independent table. And here are some values that have gone into it. Okay. So now when I run my script, and then what I did was select all the records from all the tables, show all records or show contents of all tables. Guys, I request you again, and I'm really serious. I have to get serious. I never get serious till the end of the semester. Please do not give me extra statements if I'm not asked for them. I have asked you for 4 outputs. I get 14. Believe it or not. Every statement has a describe and a select. Describe and a select. You write 5 alter statements, you give me 5 selects. I haven't said show me the tables in the database. You give me show tables. I haven't said what table. Like, I'm tired of looking for the right out. I need 4. It's so easy to mark an assignment 1, 2, 3, 4, and now I have 14. And believe me, I have them. Like, I really have them. And I should give you a 0 in efficient and redundant code. And 2, scripts are not running again. And I'm making scripts run. Like, and you know what? This happens. It happens till the end. I keep marking it and marking it for assignment 4 in that order. I forgot to say I will only mark what I see. And so I have scripts that are not running. And now here I am trying to make scripts. It takes me ages to mark an assignment if I have to do all this. So I've been marking your assignment 5, the alter one, since past 2 days for sure. I'm 70 students. It takes me time, right? Some of you are so nice. I just have to run it. Everything looks good. I check. It takes me 2 minutes and I'm done. And sometimes I have to devote half hour to it because I'm looking for the answer. Guys, please have mercy on me. Therefore, I didn't give you another assignment. I'm still marking the previous one. And I'm saying if I give you another one, I have a 70 more to mark. But joins are coming. And I'll be very careful of saying I'll only mark what I can see. I really will. I really become strict when the work increases, the workload increases, okay? Okay, so it should, there is nothing else. We will do something, but there is nothing else. So this script should run completely and correctly. And let's run it. And we must have 4 tables. So that's your first table, contacts, the current table, the desired table, and the listings table. Now, in the real world, tables are created first, relationships are created first, diagrams, which are called ERDs, entity relationship diagrams, are created first, and then coding is done. I mean, everything is designed first, and then coding. It's like building a house. You first design, and then you get it from an architecture, get it all approved, and then you build the house. But today, I'll tell you, assuming that I had done it before, I'll tell you how to now see a representation of these tables and relationships in my workbench. So if you go to, so once, please run the script once. So the database is ready, the tables are ready, everything is okay. So run the script once, and of course it should run successfully. Now go to database. And I'm doing a reverse engineering here because I'm going the opposite way. I already have the script, I've run it, and now I want to create an ERD. It should be the other way. You create an ERD. There are many software programs out there that help you to create ERDs, entity relationship diagrams. And that's what, I mean, I'm not a developer, so I don't know about all of them, but I know about this one because I use it, and I always go the opposite way. I do reverse engineering. So under database, you will have a reverse engineer. Click on it. The reverse engineering, as the name suggests, you're doing the opposite, right? So it says, okay, what is your connection? Which connection you're working with? Does your connection look okay? And if you have the right connection, everything should be fine. You go next. It says, okay, the following tasks will now be executed. I have connected to the DBMS. Your connection was correct. I have retrieved the schema list. That means schema means all the databases that are available. I have the list, and I have checked the configuration issues, if any. So everything looks okay. Nothing is wrong here. Let's go to the next screen. Now it says, okay, which schema or database do you want to work with? Whose ERD do you want to create? Now, unfortunately, I have a lot sitting there. You may not have one, but we just remember I made it once. See, so there was some problem deleting this DB jobs for whatever reason. It's just something, an error was occurring. So choose the database that you just created. So your list may be small because you've only been working for 6 weeks. I'm lazy. I just keep working in the same directory, and therefore I have many. Every time I think I'll do it and I forget. Now I'm getting a new laptop, so it will all be clean for the next semester. Okay. So pick up the database that you just created. Go to next. It says, okay, I've retrieved all the objects from this schema, it is called, from your database, and it looks okay. And I say next, and it says I've imported 4 tables. Remember, we created 4 tables. So it says I've imported 4 tables. And now it says place imported objects on a diagram. So you want to create a diagram, an ERD, and say execute. If things are okay, if your script has run fine, you will, the next is not a big deal to see. It says 4 tables, summary, and so on. You can do a finish. If you have everything going okay, and you had my script, you will notice that you will have a diagram that will look like this. The job listings table is the easiest to understand. It has, now let's kind of look at what they mean, right? And every software will have its own coloring, coding, or whatever. It's saying that job ID is the key. Notice how the yellow, it's a primary key of this table. If you kind of click on this indexes, what is an index? Index is, it creates a sorted, it creates automatically, it will create an index on the primary key. What is an index? Something that helps you look through a table, like an index of a book, okay, at the end. So that's what it automatically creates, an index. Every table has a default index on the primary key. Therefore, I have mentioned this before also, that whenever you want to do searches or updates or deletes, always work with the primary key because it already has an index, right? And looking something up by an index is much easier than page by page. So if you want to look up for the word, I don't know, something that we were looking up, for example, engine, storage engine, would you go through the whole manual page by page? Of course not. You will go to the index, you will see where this is occurring, and you will click on that page, right? So that's what an index is. So if you go and click on all of these index, by default, it creates an index on the primary key on its own, which makes you believe that you can also create indexes if you like on non-primary keys. So there is a create index command for your information. Not in our codes, but not a big thing. Like you create tables, you can create an index. And what is an index? It is a kind of, as it is an index, which says this record at this position, this record at this position. Okay. Now let's look at what it is. I'll go there so that when I'm recording, it's you can hear it afterwards also. So the yellow one says I'm a primary key. The zip, the salary, and the title are diagonals, right? They're kind of diamond shaped. The white and the blue coloring definitely has to do something. What is the blue coloring? Salary is not related to anything. Oh, maybe with not null or null. Can we go back and see? In job listings, salary is not null. The other 2 fields are null. So they are diamonds. The blue diamond says that this field is not null, right? So there has to be some kind of connection. Okay, let's go back to our, they call it the EER diagram, extended entity relationship. In the common language, they're called ERDs, entity relationship diagrams. Why? They're telling you the relationship. Now, so now let's look at these 3 tables which are related. 1, yellow key means it is a primary key. Okay. A red means it is a primary key, but it is also a foreign key. So it has 2 things. It is definitely a primary key because there is a key symbol. But it is red in color instead of yellow because it is also a foreign key. Again, the blues, these were all not null. Some are null, some are not null. And again, red is a primary key for sure, but it is also a foreign key. Okay, now this relationship, the 1 to infinity that you see. Now, if you want to change, I'll show you a few things. Where is it? In tools? I can't remember. Where is it? Database. I'll show you. You may not have this single lines. You may be having something else. Model, maybe. Model. Add a diagram, object, relationship notation. Here, you can change this. You can go crow's foot or feet as they're called. Right? So if you see, if you change this, it is under model. This is a model, right? What has happened is instead of seeing a 1 and an infinity, the 1 is replaced by like a dash, which looks like a 1, and the many has been replaced by this, which is called a crow's feet. Therefore, this is called a crow's feet notation. So this 1 here is not a 1. This is just a notation, right? It's just like when you draw crow's feet, you're drawing these. Okay? And similarly, there are 2 ones there, but one of them is just the connection that 1 is there. So why do I like what I do? I tell you. Here, it shows you a relationship that there is a one-to-many relationship between table contacts and job design. For example, me, for example, anybody contact ID 1 says, oh, I want to be a DE. The one says, I want to be a baker. The one also says, I want to be a something else. So you could have contact ID 1 many times in that table, but it will only occur once in the other table. Therefore, it's a one-to-many relationship. 3 kinds of relationship exist between tables: a one-to-one, a one-to-many, and a many-to-many. Mostly, it will be a one-to-many, but the other 2 relationships are also prevalent. Okay, so many-to-many means many of the many here. One-to-many means one of it here can have many children here, and one-to-one means one of this can only have one of this. Okay, so our tables usually will be one-to-many. Now, this is called the crow's foot or feet representation of relationships. If you notice, there are a few more. So if you go to relationship notation, the classic one is this. It uses these diagonals, and you can look up what the diagonal means. The 1 is here, and the 1 dot dot star means many. Okay. Now I can't remember because I don't use it often, and I have never used it. But there is something that you can look up and see what does this mean in my workbench. You'll have to go and look it up. It's not a standard one. Or maybe if it's here, we can look it up. No, I don't see it here also. Sometimes when you create a diagram, it's mentioned here, and then you can see what it means here. I would never recommend that you delete this relationship, because this is what will help you to answer your questions when you do jobs and joins and subqueries. The third model, the third notation is connect to columns. This is the one I use. Why I like this? Because it is giving me the relationship one-to-many, but it also tells me that the contact ID column there is connected to the contact ID column. So I don't have to kind of remember which field is referring which field. Here it was easy. They were both called contact ID. But if there I chose it to call contact ID and I call it something else here, then I may not remember it. But of course, I mean, you do learn to remember things when you work on an application. But this gives me a clear picture that field contact ID is linked to this field contact ID. The red and the yellow are telling me they are primary keys. The red is telling me it's a foreign key. The one-to-many is telling me it's a one-to-many relationship. So I prefer to use this relationship notation. You're free to use whatever you like. It just makes it easy for me to remember which field is related to which field, though I kept the same names. This is called an ERD diagram. This diagram needs to be drawn before you write your code. Why? Because the database designers draw it. So they say these are the tables, these are how they will be linked, and so on. Once I have an ERD, now all I have to do is just convert it into code. But I'm going reverse engineer because I don't want to do it before. But you can draw diagrams yourself. You can add diagrams yourself. You can add a new diagram here, and you should know how to draw them. So I haven't ever drawn them in my SQL workbench. I've always gone the other way. But there are other resources also. I'm not saying workbench is the only one that allows you to draw diagrams. I'm sure there are many more, right? But you should know to draw them by hand, or if you want when I ask for it, you can take a printout of this, but then you give me a legend. What does yellow key mean? What does red key mean? I don't know what they mean. What does 1 mean? What is this? So then you tell me what it means. Because a diagram given to me makes no sense if it doesn't have a legend. Okay. So when you're required to draw one, just don't give me a printout. That's a 0. I know you've got it from here. If it has a legend, please see that you understand what it means. So diamonds are just fields. The blue ones, and again, a black and white, I won't be able to make out the difference between red and yellow keys. So when you're taking output, if it's not colored and black and white, then you make it colored. So it will be asked of you. I will be asking ERD from you because this is a diagram that will help you when you start writing joins and subqueries. It's a very friendly diagram. You don't want to keep going back to descriptions of your tables. You want to look at this diagram. So in an assignment, take a printout and keep it with you. And I'll keep referring to this when I answer my select statements. Okay, so it's an important diagram. And we don't have to do much in it because you can save it also. At the end of the day, it can be saved. You can take a printout or whatever, but I will use it when I do my answering, right? So the ERD is ready, but it should be ready before you code it. Having said that, now our job is to start answering queries. We'll take a break here. I see tired faces, which is okay. It's been a while, an hour or so, and then we'll answer these queries. And then after I do this kind of a something that is available, union, intersect, all, and so on, then I'll start generic. If union, just start writing our own queries on it. First, I'll use what is available, and then we'll start doing our own queries. Okay? So we'll take a break here of 20 minutes. You could have your lunch or whatever it is, and so will I, and then we'll come back and start working on this. Okay?
20 कलाक की पर 1 मिनिट में पूरे 20 कलाक की ऊपर 1 मिनिट में नहीं पता है तो बीस कलर ऊपर वाले दो कौन सा अपने हम बे महीना ने कब तैयार करे कोई नहीं ऐसी I know it's smooth. Technical questions. Ini sebelum mengajar pada mana? Kata kuda biasa sampai ke bentang gua pula gitu. Itu dia nak buat. Dari mana kan?
वही जिसके साथ तुमने काम करना होता है वो भी टेक्निकल
नहीं वही था मतलब
बट मेरे दो इंटरव्यू दोनों ने ऐसे था कि जिसके साथ काम करना है उन्होंने
तो मैंने भी देखो
I don't know that. Like the one thing I even I saw this is even a speech he said it was he wanted that's the thing. Okay, background.
नहीं बहुत टाइम
हो जाएगा
What is this? What is what people doing? I want to do I'm looking for
ऑलरेडी बाहर एक चला
તમારો આવશે રવિવાર દંડો
Alexi, you had a question. Alex? Oh, it's cold in here, isn't it?
I didn't figure out how to put the VIN numbers in because
Yeah, okay, so you can't insert them. The data is already available in the table, right?
And it,
so you
and
update
it creates
them.
new.
It creates new columns. So now you update them. So update the VIN where car ID is 1. Update the VIN where car ID is 2. Update the VIN where car ID is 3. You can insert new data, right?
Yeah.
So where you went wrong. And I'm thinking, Alex is not thinking what's going on. Usually your
Sometimes
scripts are perfect.
we do very silly mistakes, and
You don't realize.
it takes a lot of time to figure it out. And sometimes I just can't.
Email me and say, I'm stuck. Okay, I'll say use update and the rest you can do yourself. You know what I mean? And somebody asked me in class because they were doing insert, and I said, no, it can't be inserts. You're not adding new records, you're updating records. Right? Okay, no problem. Okay, guys, a few things that I must mention because it will keep coming. I mean, maybe not necessarily every week. When you alter a table and you've added new columns in it, you update the table and not insert new records. Insertion can give you problems. You have an auto increment field and now you're inserting more records. So when I say add fields and now change the win value, for example, in your assignment 4, which I know is it's a couple of weeks back, you may not remember. It's not always insert that will work. You are updating the column. So you're changing the values in the column. And very important thing that I've seen in at least 3 assignments of the 30 I've marked. When you update a table, you always update a table on the primary key. You don't say set win where car make is equal to whatever. You can't do that. Why? Because you're seeing 3 records, but there could be 100 of records. And make can be duplicate. You can have more than one of the same make. The question said win numbers are unique to a car. And they can only be unique if the car you're using car ID to update them. If you're using the make to update them, then how can they be unique? I mean, I know there were only 3 records, but logically you cannot update them on. Therefore, I've always said when you do something to a table, you update something in a table, your first thing should be, or deletions also, your first thing should be, can I use the primary key? Sometimes you cannot, sometimes it's a different question. But when you're updating the win number and the win number for every car is unique, that means you have to uniquely identify a car. And who's uniquely identifying a car? The primary key, not the make or the model, right? It's not identifying. 3 records doesn't mean, oh, that's the only 3 records. The 3 records were just so that it was easy to do, right? So I'm marking that assignment, and fortunately or unfortunately, if you've missed anything, appropriate types, not best fit, everything you've learned should stay. So when I say appropriate types and you're not doing it correct, you will lose marks, right? How much? The price cannot be an unsigned number. It should be unsigned. It needed 3 places after decimal, but it didn't need 10 before the decimal. So I'm seeing 20, 10. What kind of type is that? Like, what kind of size is that? You know what I mean? So I will give you feedback. I'm marking it. As I said, it's just taking time because I have to run it, and then I have also to look about comments and see if you've done the right update, and because you could be doing things in different ways. So hopefully, I'm hoping, because I teach Wednesdays and Thursdays almost full days, like I finish at 3 and 4. Hopefully on Friday when I don't teach, I'll be able to wind it up. And you should have it by Friday night, right? I'm aiming at that. Oh, well, like you, I'm always procrastinating. Okay, let's try now. Okay, so you know what ERDs are? You know what foreign keys are, and you know what primary keys are. All these tables for your information are in the first and the second normal form. I'll talk about second when I see a table that is not in the second normal form, or I see a composite key. So whenever your primary key is a single field, it's automatically in the second normal form. You don't even have to kind of worry about it because the definition is talking about a composite primary key. So when it comes, hopefully I'll show it to you. Okay. Now, everything looks good, ready, and fine to go. So a few things that I'm going to do here, I'm going to use something that is already available, like the union verb, but then like it doesn't have intersect, for example. MySQL doesn't have it. It doesn't have the except, for example. So then you will have to think of your own solutions. Okay. And in the long run, anyway, union, intersection, and except don't work for everything and anything for all applications. So we have to learn to join and do subqueries anyway. Okay, so let's start. What is union? If you've done a little bit of math, or if you haven't, the normal English word union means joining, right? So take everything, put it together. That's what union means. In the math word also, union means take everything from both of the sets. We do it in sets in math and just put them together. So it says removes duplicates, and there is a union all that keeps duplicates. So if you want to keep duplicates, good. If you want to remove them, then you use union. So it says to get all possible job titles from all the 3 tables. You'll say there are 4. My contacts has nothing to do with jobs. So I'm looking for all the titles. Titles were in the job desired also. Titles were in the job listing also. And titles were also in the current job also. So you'll say, what will you do with them? Maybe afterwards I'll count how many want to be programmers or how many jobs. Don't think about why. For now, I want to show you the union verb. Okay. So this is how you do it. So MySQL has a union verb, and that union verb, I don't know what else to call it, will take whatever you tell it to take with duplicates or without duplicates, depending upon what you use. So what are you selecting? Excuse me. You're selecting the title. Now they could be called differently in all 3 tables. One could be calling it title, the other could be calling it present title, the third could be calling it desired title, whatever it is. So we have to do a select from each one of the tables. For us, they're called title. And again, instead of going back in the script, I can open my ERD and I'll say, oh, it's called title here, it's called title here, and it's called title here. It could have been called 3 different names. That doesn't matter. What I want you to do is collect all of them. Okay. So that way this ERD comes handy. So select title. Oh, bless you. That was a big one. Okay. So the 3 tables are table job current. That's one table. Do a union with. Do the same thing for the other one and do the same thing for the third one. So the table names will be different. There will be one field in the answer because you're only selecting. I mean, you can't select more than one when you're doing union, because union means pick up a field and do it. So the second table was called job desired. And the third table, I think, was called job listings. Let me double check. Yeah, listings. And there it is. So when you use union, it will automatically remove the duplicates. If you keep union all, it will keep the duplicates. Okay. So since the script was already run once before, here is your answer. Duplicates will be removed. You can try it the other way. So it's just kind of giving you a picture of what's in the market. People are designing what kind of jobs and what are the jobs they're already working in. So as I said, not necessarily the best of use, but whatever it is. Okay. So that's the union verb and has a sibling called union all. It is available in all, including MySQL. It is available in almost all relational databases. Let's look at the second one now. It says produce the job titles that are common in the 2 tables, listings and desired. That's a more valid question. So people are desiring and are they available? So that's a more valid query. So if I want to see what are the titles that people are looking for and are available, this is a good one. You have the verb called intersect or intersect all. Unfortunately, it is not supported in MySQL. But if it was supported, then all I would do is this. So job current and job desired. No, sorry, job desired and job listings. And this is a very valid question that one could be asked of. Bless you. And again, it removes or keeps duplicates. Right, so that's what you would do. You would use the word intersect or intersect all, same way like the first one, keeps duplicates, removes duplicates, but it is not available in MySQL and therefore you see this squiggly error. So we can do it. But definitely it's a very valid question. So we must be able to find out what are people desiring and are they available in the listing. So which desired jobs are available in jobs listings? Let's now try to do it using our own logic, right? Our own join statements. So intersect is not available. So what are the, now think about it. What am I looking for? Which fields am I looking for? Title. What are the 2 tables or 3 tables or 4 tables that are involved? Job desired and job listings. What do I want to match? Basically that they're present in both the tables. Okay. So first form in your mind or write on paper, what am I interested in? So what are you interested in? What tables should be joined and what should be the joining condition is very important. If you leave out the joining condition, your answers are always almost going to be wrong. Because if I don't have a joining condition, I'll just show you, if you don't have a joining condition, everybody says hello to everybody. Let me try to show you what a joining condition does without a join condition. Okay, so what do we want to select? We want to select the title. From which tables do you want to select it? Now, there are a few ways of writing this. You can start using the word inner join. You can use the word, you can use comma. You can use, like, there are different things. I'll show you a couple and then you can choose whatever you like. So I'm interested in the job desired table. Now, one way of writing it is the word inner join. And in a minute, I'll tell you another way, and a third way, and a fourth way. Okay, so there is one. So you're saying join these two tables. Why? Think, why are you joining them? Joining means I want to look up these two tables, right? I want to look up these two tables and I want to find out, is this title available here or vice versa? Is this title available here? So you have to kind of look at two tables, right? Only then can you give this answer. Okay. So first, which fields are you interested in? I'm only interested in title. Which tables are you interested in? Now, one option is writing the word inner join. There's also something called outer join. There's also something called natural join. So we'll talk about all of them as we go on. So one is this, inner join. Now, if I leave it at this, and I just leave it, nothing. Let's see what happens. How many records in job desired did we have? How many job desired people? Let's look at it. 1, 2, 3, 4, 5. 5 people in job desired. And how many in listings? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. 14 into 1, 2, 3, 4, 5. 14 into 5. 5 4s are 20, carry over 2, 5 are 70. Thank you. Right? If I just do a join without any joining condition, it actually is like a Cartesian join. It's like saying, I'm going to say hello to everybody. The next one says, I'm going to say hello to everybody. The next one is saying, I'm going to say hello to everybody. This is also called Cartesian product. Let's try it. I mean, it's not the right answer. Of course, it's not the right answer. So if you forget your joining condition, your where, then of course your answer will not be right. So let's try what happens. I should get 70 records. And it's taking time unless I have an error, query interrupted. So let's see what is the problem. Spelling wrong? Thank you. Oh, doesn't matter small or caps, but whatever it is. Again interrupted. Now what? It still says stable job listings. Have I? That means this was wrong from where I copied. Can't be wrong here because it is running. I'll kind of copy paste here because it's causing a problem. I don't know what I did. I don't know, but let's try. At least I know of one error. I know what the other error is saying. Now, there is a little bit of ambiguity here. It says, okay, I'll join the two tables. Let me show you this first. Maybe this much will be much. Okay, so here, join the two tables. Nothing, no criteria, nothing, all the fields, nothing. How many records are you expecting? 70. There you see the answer in the output window, 70. That's an inner join. It just, every record says hello to every record. And for your information, this is also called a Cartesian product from math, right? So if that's what you want, good enough. It is available, you can do it. But the question is not what it is saying. The question says which jobs are available in job listings. And it didn't say anything, but I'm kind of giving you the title because that's what kind of makes more sense. But you could have shown a star also. Now comes the condition. Now where? So I'm trying to bring to your notice that if you forget the join condition, your answers will be wrong. And believe it or not, always in a class, a couple of students will forget it. And then, of course, can't do much about it. Now let's write the where condition. Okay, now what is your where? For us, the where is simply saying compare the titles. right? It's saying compare the titles. So compare the title of the first table, which of course we don't go first or second. We say compare the title of job desired by the job listings table. That's what you do. So let's do it. It's as easy as this. But if I write title is equal to title, of course you are confused too. Which title are we talking about? There is ambiguity here. So some programmers do not like to have the same named fields in the two tables. Others prefer it because it's easy to understand. You could have called them title 1, title 2, but kind of silly. So there is a way out. What you do is you qualify your titles. So keep the name of the table before it, dot. Keep the name of the table before it, dot. And since I'm working with strings, it's always a good idea to work with the trim function, because if there are any extra blanks before or after, they will be removed. Though I think I have to reread it. I think I understood that if I say not null, strict not null, it will still work. That's another advantage of saying strict not null. Your setting where you say strict all tables. Now it's making sense. It is saying the same thing is happening. The first record from the first table goes and looks for a partner in the second table. If it finds it, so it's kind of doing it with everything. Are you my partner? Are you my partner? Are you my partner? Are you my partner? If it finds it, it spits it out. If it says no, then it doesn't spit it. So remember, joins are time consuming. So writing them correctly, or writing a subquery as you will go on, or writing an inner join or an outer join or a natural join, you will notice that things are kind of not that easy. Okay, like you have to be careful. Now the same thing, just for your information, I can write the same thing. You get an error? What is the error? Where is the error? Oh, did you put a space after the trim function? No. I'm okay. I'm getting 70. What else? What is the error? Bring your mouse to the error and say, what does it say? Oh, I see what you mean. Oh, okay. Right. I see it. Same thing. What we did here. Both the fields, I forgot to do this, sorry. You have to qualify them everywhere you use them because there is ambiguity. Oops, thank you. Yeah, of course you will have an error. Right? Yes, because no ambiguity now. So do you want to choose different named fields? Go ahead and do it. I'll stick to this. Just because title makes sense, title. Title is the title. I don't want to call them title 1, title 2, title 3. Then I'll have to think, oh, did I call it title 1 in my first table? Who wants to do all that? So title is a good enough name. So nowhere should there be any ambiguity in your code. So since title, so it says, okay, I'm going to select title, but there is a title in this table and there is a title in this table. Which one are you interested in? Right? So you have to be unambiguous. Let's try it again now. Now something else? What is my output? I don't know. Let's see. I haven't tested it yet. The output is, I think people were looking for Baker and computer programmer. Now I see computer programmer twice. That gives me an idea. Now I could be entirely wrong. There could be 2 computer listings and only one desired, or the opposite. 2 people want to be computer programmers and there is only one listing. So I don't know what's going on with what. I have no clue, right? If you just want to get a general picture, oh, I want to just see what's common, you can remove it by putting the word distinct in front of it, and it will remove duplicates. We did distinct last week. So if you don't want to use duplicates, all you do is distinct. It depends on what you're trying to do. It's like intersect and intersect all. Do I need to see duplicates? Don't I need to see duplicates? So that's the result of intersect is not available, but this is available. Now I want you to show a few things, a few variations, and I leave it to you. You can choose whatever you like. The word inner join can be replaced by a comma. And I know many of you will kind of quickly jump to it. Let's do right. So inner join can be replaced by a comma. That's allowed. 2, you can give alias names. So that means another name. So job desired, if you like, you can give it a name just because they're short. You can call it JD. Like Muhammad is called what? And job listings. And then now the uses, you can go JD. And it's just shorter, right? It's just shorter. You don't have to. It's up to you. There is extra work that you have to give them alias names. So they're also known as, in this query, only in this query, job desired is also known as JD and job listings is also known as JL. So these are called alias names. Like you give names to your display columns, you say as, these are the same things. And I'm sure if that's allowed there, the word as will be allowed here also. Yeah, looks okay. You can say as also if you like. So you can do it with as, you can do it without as. These are called alias names. Some people prefer it because sometimes table names are very long and it's just easy. Again, it's up to you. Okay. So that's another way of writing it. Now, I could do an outer join right now, but I'll try to restrict myself a little here. Okay. I can do it in another way by using outer join instead of inner join, but I'll just wait maybe a week more just to get you accustomed, unless I mean, I have done it, of course, but anyway. Now, another thing that is easy, that's not a tough one. You can do this. I'm just placing it here just because it's before the comma. If, let me put a, now here is an advantage. If the fields in both tables have the same name, the title was called title in both the fields, in both the tables, then you can do this. Oh, so please complete that natural join. And you are doing equality. And the where is looking for equality. So both conditions have to be satisfied. One, the name has to be same. So they were called title. And what am I doing in where? I'm looking for equality. They're both equal, right? If that's the case, only under these two circumstances, if that's the case, then you can do a natural join. You don't have to give the condition. Automatically, natural join will pick up the title from the first table, title from the second table, match them and give you the result. But you still have to say which title am I interested in, though there is no difference. When titles are the same, it doesn't matter. You're matching on equality. So they both will be the same, but you still have to say which title do I want to pick up. So that ambiguity you still have to do, but you don't have to write a where condition. But the same named fields on equality only. If it was not equal, I couldn't have used natural join. If it was greater than, I couldn't have used it. I cannot do it. Right? Now, the only thing that I want to double check, and I think I've read it, I'm going to do this just for the heck of it. Computer programmer was coming, right? I'm going to put some extra blanks here on the right and the left of both of them, right? Just for the heck of it. I know this will work because the trim is trimming it. I know this distinct. Oh, because of distinct. Okay, so this will work. Let's see what natural join does. Does it automatically also remove blanks? And again, I'm mentioning this because of the strict alt tables that I've read that it does it, not because it's a natural join or anything. Let's see. Do we get it? What doesn't exist? Oh, the word join is written twice. There. Okay. Now I'm going to do something, and this has been troubling me for so long, but I haven't had time to test it. I'm going to remove, or do I even have it? I'm going to remove this set SQL mode to strict all tables. Either I read it wrong or I have it wrong, but whatever it is, I'm going to run the whole thing again now. And I'm going to check my results. So this is the one which says no, technical writer. Where is technical writer coming from? Okay, this is where I start. So Baker and computer programmer, see here. Strict all tables allows you to put extra blanks on right and left and automatically trims it when it makes comparisons. But did I check it before I did the natural join? I think I did. Now that I have removed it, so it's not only for the not null, it's also for this. And I thought I had read it. And then the third and the fourth are okay because I'm using the normal trim. All I did was I replaced the comma. Inner join was replaced by comma. But the natural join is not giving me the right answer because the computer programmer has blanks on both sides in the second table. Now I'm putting my set SQL mode back to strict all tables. And if I read it correctly, I'll know it now. Otherwise, we have to trim it. There is no other way. So result 24, 23, 24, 25. No, it's still not right. Okay, so I'm wrong. I had this in my head that strict all tables does it. I'm sure I read it. Anyway, it doesn't matter. Okay, so I'll go back to what it was in the sense that now we have to be careful that natural join will do an exact match. So if there are extra blanks on both sides, then it just doesn't work. It doesn't. So that's another thing you have to do. You have to keep in mind for natural join. Exact match, no trimmings, nothing. And I can't write the trim anywhere. Can I write it anywhere? No, because I don't have a where condition. I don't have a where condition. So it works otherwise, it will work, no problem. If you take it and make it work, if you work with it, it will work. Oh no, I changed it. So I'll have to do a Control S and run it again. So this one. Why is this saying a result? Oh, there was another one before it, union. Therefore, anytime it says result, it means it's not showing a table. Otherwise, it gives a table name. So there is your natural join, and natural join is working now. So with natural join, the fields in both tables have the same name, and where is looking for equality. And now we know something. Please keep in mind, trim is not automatic. So extra blank is there's an exact match, including blanks on either side. There's an exact match, right? So that means extra blanks will cause, bless you, extra blanks will cause problem. Exact match, no extra blanks. Can't you just sneeze a little more delicately? You know, like how girls do. Have you seen? I'll show you if it comes to me. I used to do it, and my kids used to say, "Mom, what's that? Can't you just sneeze naturally?" Like I said, "No, then it looks as if the whole earth is moving." So yeah, I don't do it naturally. I try to be a little, you know, girlish, but of course that's the natural sneeze that comes. Okay, so exact match, no trimmings are done automatically. I'll show you if it comes someday. So please make this note for yourself. And now I will have to go back and read about strict all tables again. I don't know. I had it in mind. Okay, done. So I've shown you 3-4 ways, kind of. One with the inner join, one with the natural join, one putting a comma, and one with alias names. You can choose whatever you like. There is no restriction unless the question specifically asks you, because if I'm saying I'm going to test you on this, I'm going to test you on this, then that's what it is. Otherwise, it's up to you. You can do it. Oh, one more interesting one. One more interesting one. Okay, so you can do this also. And this is interesting in the sense that it's easy. Again, the field has to be named the same. That's the restriction here also. Oh. Here, that's another one. So you can use using if the fields are, oh, so we won't know. I'll have to check about that blanks and trims. I'll have to check about that trimmings. I don't know. Like I really don't know. I've never kind of paid attention to it. But keep in mind, when you use using, you cannot use a comma. It will give you a syntax error as far as I remember. Yes, see, you cannot use using with the comma. Using has to be used with inner join. Oh, so what did I do? Control V. Okay, Control Z. Control Z. Control Z. There. So using if the fields have the same name, but you have to use the word inner join. Can't use comma. It won't work with the comma. It doesn't. It gives a syntax error. So we don't have to go even there. It gave you the reds quickly. Okay. There's another way here. There's another way. Now the only thing I don't know about is the trimming. So again, for the trimming, this is all I can do. I can put computer programmer here. I can put computer programmer here. I can do a Control S. I can run the whole script. I don't think so, but no, it doesn't. So again, no trimmings are done automatically. So I'll find out a solution if I can. I read somewhere that these extra blanks are ignored in a varchar field if you do a setting. And I'm almost positive it sets strict all tables, but of course it doesn't look like it. Maybe the engine is different. I don't know, but I'll look it up, right? Now, if I run it, I should be okay. We just added using at the end. So there is my answer, right, for the end. So again, some people prefer it because it's easy to write, right? Natural join is easy to write, using is easy to write. But at the end of the day, you must understand that what am I doing? And again, you can put a note for yourself, no automatic trims, because we just found out. Now this will bug me till I find out the solution, because you can't keep doing this. I mean, I can't use this because there are extra blanks. So there has to be some setting condition that will help me. Anyway, we'll come back to it. So that's another solution. So use the word inner join, use comma, use natural join, use using, whatever makes sense to you, you do it, right? It's up to you. So this is 5 different ways of doing the same thing, but it does give me an answer of what I want. Now the except and the except all. Let's see what is this except and the except all. Again, it is not available in, the question is missing. Sorry about that. The question is missing. The question is a list of job titles. That's strange that it's missing. But anyway, a list of job titles that are in desired, in the job desired table, or we can say that are desired. I mean, you should know what it means, but not in the job, but not in the listings. Oh. So it's basically saying they are desired, but they are not in the listing. So that's why it's except. Okay. So again, it won't work in SQL. It says it won't, it's not supported. But if it was, I'll just write it for you because, I mean, you should just know the syntax. So I'm going to select, okay, title from and you use the word except here or except all, whatever, depending upon. Actually, there is another one which is also not supported, but I'll write it. Maybe here I can show you outer join. It will be a good one to show you an outer join. So this is not supported. And just so that you know, some languages, I can't remember, what is it, Oracle or DB2? I can't remember which DBMS. Instead of except, they use the word minus, which is kind of the same thing, right? Minus it. But neither will work, I think. Neither, they don't work. They both don't work. So I'll just put it in quotes, in comments for you, and we will find our own solution. You tell me how to do for it. Let's look at it. It says, I want a list of job titles that are desired. That means they are in this table. People are looking for it, but they're not available in the listings. It could have been opposite also, but it's like, oh, I'm looking for this job, but it's not available. It's more a valid question. So what do you think? Logically, what do you think you have to do? In a way, you have to think about it. You have to pick up a title from the job desired table, search for it in the other table, and if it is not found, that means it is in the answer. Right? If you kind of think of it, that's what you have to do. Pick up a title from the first table, look it in the job listings table. If the title is not there, that means it is desired but not available. So how do we do it now? Now the main thing is, how do we do it? So can we use an inner join? No, because inner joins are usually saying join this table with this table when their titles are equal or unequal or something. You'll say, let's do the unequal. The titles are not equal. That's what I'm looking for. But that's not the right answer. So you'll say, let's do the inner join that we were doing before. And it could be the first thing that comes to your mind. And I'm not saying it's wrong, but logically look at it, what will happen. You'll say, oh, it was equal. Now I'll use not equal. Remember, there were two not equals. You can use this or this. You'll say, that's what I'm looking for. Your title is not equal to that title. But if you kind of think for a minute, what is it doing? It picks up the first title. Let's call it A. And then it compares with all the titles in the second table. If it finds an equality, good. If it doesn't find an equality, it will print it out. But it has already found it. So it could match something. It could not match something. When it matches, it doesn't do anything. But when it doesn't match, it will print it out. So that won't work logically. Try it. Right? You are basically saying, so who was looking for job? 5 people were looking for job. Baker and computer programmer are already available. So sales manager and chef are not available. So that should be my answer, right? People are looking, but think about it. So this guy picks up computer programmer from here. I mean, not this guy. My query picks up computer programmer. It compares it with Baker. They're not equal. It will spit it out. It's not equal to clown. It will spit it out. And it will keep spitting it out. And then when it reaches computer programmer, it will not spit it out. Like it's not doing the job at all. Right? So logically, we'll say, oh, they don't match. That's the first thing that will come to your head. That I'm looking for those titles that don't match. So let's see. They don't match. Okay, let's see. Let's run it. That's not the right answer at all. It's not. Right? Because we definitely saw that computer programmer had a desired one and the other one also has a desired one. Why don't you see all of them? Because I have distinct here. Remove the distinct and things will be different. Right? If you want to show both pairs, see, this is what is happening actually. So that you know that this is logically not correct. I'm going to show you both titles. And I'm going to prove to you what I was saying. Everybody who doesn't have a match will match. So I've taken the title from the desired. I've also taken the title from the listings. I've joined the table and I've said don't match. Now this will be more clear. You'll see this answer will be more clear to you because you can see all that they don't match. See. Look at the long list. Wherever there was not a match, it spit it out. That's not what we are looking, and that's not the right answer. So logically we'll say, oh, it doesn't match. Show it. But if I'm only showing this, and it's all over the place. And it's correct. That's exactly what you've told it to do. You don't match, spit out. Don't match, spit out. Don't match, spit out. And then why was I showing 4 answers before? Because I had a distinct in front of it and I was only showing one title. So definitely you weren't able to see that this was not the right answer. It is not the right answer, right? It is not the right answer. So I had distinct here. So I was only seeing 4 answers. But if you I showed it to you now that it's not what it is. So this is not correct at all. So not the correct answer. I hope it makes sense. It's not as easy as, oh, they don't match. That means inner join doesn't have a solution for this. Inner join doesn't have a solution for this. We need another kind of join now. This is the right place to show you the outer join now. Okay? It didn't work. Just saying it doesn't match didn't work because logically it won't. It's like saying, okay, I'm wearing something pink and I want to match. I want to see if anybody else is not wearing it. I mean, I'm just going to everybody and saying, oh, not match, not match, not match. And if I match, logically it's wrong. Now, what do I do then? Inner join doesn't work, definitely natural join will not work because it's a special case of inner join. Now you require a third type of join. It's not a third type, it's actually a second type. Natural join is just another way of writing it. It's called an outer join. Outer joins come in two flavors, a right outer join and a left outer join. I'll explain them to you. Please understand them completely and correctly. They are difficult to understand. So I'll do them step by step. Okay, one by one. What is an outer join? We'll do that first. Okay, so I'm going to pick up not the right thing to pick up, but at least something to start with. And I'm going to put a star here. Okay, I want to show you all the fields of both the tables. Okay, instead of outer join, I'm going to write, I'll show you both right and left. I'm going to show you a left outer join first. There is nothing called outer join. It's called a left outer join or a right outer join. And I'm going to show you something. So one by one. Okay. So what am I comparing? Titles. What am I comparing? Titles. Okay. I still see a red squiggly. Oh, no. What is it? Where? No. Here we do an on. Syntax. This is not the answer. Okay. I'm going to show you step by step what a left outer join does. And then I'm going to take you from there and kind of follow you through. So please understand this clearly and completely because it will come over and over and over again. Okay, let's see what I have done. I've said that these two tables needs to be joined. You have job desired that has some fields. You have job listings that have some fields. I've just said star because I want to show you the whole thing. And I've said do a left outer join. Left table is important, is the master table. And the right table is the child table. Now, what do you mean by master and child? We'll look at it. And I've said wherever you see an equality, you just make a join, right? But let's look at the answer first and then we'll discuss it. So let's run it. If everything is okay, I should have an answer. And I want to bring your notice to a few things now. Now, please understand it completely. Baker was picked up from the job desired table and it found a partner in the other table. So look, 10 Baker, whatever salary, low salary, high years experience record is matched with job ID 1 Baker 60,000 or whatever. They got a match. Equality. I've done, my condition says match. Okay. Computer programmer was picked up from the first table and it found a match. Computer programmer was again picked up from, there are two computer programmers in your second table, in your first table, in your job desired. It also found a match with the same computer programmer, but it found a match. Sales manager was picked up from the first job desired table, but it did not find a match. What happened to the rest of the fields? They became null. Similarly, chef tried to find a match, could not find a match. So now I have my answers, but what should I be removing? Those extra records. How are those extra records recognized? How do you recognize those extra records? What do they have? Null in their fields. In all their fields, it is null. So now if I can say where and remove those null records, I have my answer. Look at it again. Baker from job desired found a match, match with match. Computer programmer found a match, match with match. Left table is more important right now. Okay, important means it's there where is records are being picked up from there. And that's why I want to do a left outer join, because that's my table which I want to look at. That's a smaller table. People desiring is more important to me. You can do the opposite. It will still work, but it is less efficient. It is less efficient. It will take more time. Why? Because job listings is a bigger table and it will pick up a record, look here. So it will take more time because it's a bigger table. And logically, you are looking for the opposite thing. It will still work, but we'll look at it. So found a match, found a match, found a match. Did not find a match. All the fields in the second table are null. All the fields. Now, if I can remove these two records from my output, I have my answer. And how will you remove it? Let's see how will you remove it. I'm going to just add it. You can see I'm just doing what's in the table. Where? Now you want to only pick up those records where the job now there are 4 fields: job ID, title, salary, and zip. They're all null. You can pick up whatever you like. Why am I picking up job ID? Because it's a primary key and it's easy to kind of, work with primary keys. Where I could have used any field. If I use title, then I'll have to qualify it. Where the job ID is not null. Pick up those records. Which will be picked up? This will be picked up. This will be picked up. This will be picked up. So you can use any of the fields from the second table. All the fields are null. I could have said where job ID is null. I could have said where salary is null. I could have said where zip is null. For title, I would have to qualify it. I would have to say where job listings dot title is null. Because I have to qualify it because there's title on both sides. Use whatever field. Usually, because it's the first field that comes, you see the job ID is a primary key, you just use the primary key. But you can use any of the fields. Now, if I try this. There. I'm only interested in title. So what will I do? Instead of star, what will I say? Title. And if I only want to see it once, I'll say distinct title. Right? So if you want, if you want it, we can do it this way. We can leave this. So step 1. I mean, this is not the answer. It's only a step 1. You can see how it works. Right? In step 2, I'll copy the whole thing. Only keep desired records. So in the first one, we are doing everything. Right? Just to show you how it works. How outer join works. That was to show you that, right? Then now I'll show you the left also and the right also. But anyway, how it works. Why did I choose left? And why did I make job design my master table? Because logically it makes sense that that's what I'm looking for. Here, now remove the extra ones. And step number 3, only keep the title. So this is working. This will work. Works. Now only keep the title. Step number 3. We were only interested in title. And if you want to make them distinct, then you add distinct to it. So instead of a star, what will I do? I'll put title. But remember, when I use title, what do I have to do? I have to qualify it. And you can qualify it with whatever you want, with whichever table. Really doesn't matter. They're matching. When they match, it doesn't matter. The equality condition. There. Now this will only select titles, but the titles are doubled. So what will I do? So try it. Here you will see computer programmer twice. Definitely you will see it twice. That it's occurring twice here. Two guys found a match. Now you remove distinct. Put distinct in front of it. If the requirement is. Make sense? That's an outer join. So an outer join comes handy. You can kind of keep this in mind. It comes handy when you're trying to look for something in one, but it is not in the other table. Now I've done a left outer join for you. Let me do a right outer join for you and show you the answer. I'll introduce you to the right outer join now. The same thing can be done. No big deal. When I put a right here, all I'm saying my right table is my master table. You will say, how does it matter? You will just see in the output, how does it matter? Let's run it. Only this one. I've done a right outer join. Right and left, the difference is who's the master table, who's the child table. Okay? And you have to be careful which one. I mean, I could have still used left and moved this table on the left, and that would become my major table. But I chose to write the right just to show you. Okay, now let's do this. Do you see the difference? There is a difference here. Why? Because what has it done? It has kind of tried to match every record of this table, job listings table, which is here, this job listings table, and try to find a partner in the other table. So many of them will not find a partner. At the end of the day, I can use it. Now I have to remove this records where my contact ID is null, for example. These are the records I have to move. But notice, why is it less efficient? Because it's doing more work for the same. In the previous one, the total number of records were, I think, 5. Now I have more, 5 or 6. This tells you that this will take more time. So which table to make the master table, you have to think about it first. Which table am I trying to find the answer from? So it's not wrong. It is working. I mean, I can make it work, of course. I have to do more things to it. I can make it work. So what will I do now? What is my next step now? My next step is I want to remove these records where the contact ID is null. Right? See how the contact ID is here? So what will I do? I'll add it step by step again in steps. I'll do the same steps that I did. I'll get the same result. So you choose the same thing. Now be careful of what you have to remove. You have to remove those records where I picked up the contact ID, because I can see it. See, it's so easy to kind of do it in steps. So where the contact ID is null, leave them out. What should I get? I should only get the first whatever records. First 3. Oops. Oh, not null. Thank you. Not is null, is not null. Thank you. Is not null. Left with the first 3 records. And now once I need the title, what will I do? Same thing. Pick that up. And now instead here we'll say table job desired title. Oh, now which, yeah, titles will be same. Yeah, okay. You have to think, oh, am I removing, which records am I moving? Sometimes you'll have to remove the is not null or sometimes null. And then dot title. And you should get your answer. Or distinct in front of it in case you want distinct. Sometimes you may require the opposite one. The question could have been, what's in the job listing, but nobody desires it. Then I would still use an outer join, but now my major table becomes the job listings table. So you could answer that question. It's in the job listing, but nobody even desires it. I could answer the same question. So whenever the question kind of calls for something is here, but not here, then outer join would work better or quickly. It may work with inner join. I don't know. Sometimes I can find solutions, but sometimes you cannot find solutions. You don't have a solution. I couldn't for inner join here at all, right? So now, which one is better from the two? Is the left outer join better? Is the right outer join better? Definitely, if you kind of look at the outputs, you will see that this is less efficient. Takes more time. I mean, you couldn't guess the time because, I mean, we can't. It's hardly working in nanoseconds. But looking at the output, you could say, oh, that did more work and this did less work. So in our case, this is less efficient. Again, at the end of the day, you are programmers. You should know how to write efficient code. It is working, but it's not the best of the. So I wouldn't stress this for anybody else, but I would definitely stress it for programmers. Always write efficient code. And how do you learn? From practice, right? When you practice a lot, I didn't know about it when I did it for the first time, but since I've been doing it for a while now, I can think about it, and I'm giving my thinking to you. So you think the same way. You say, oh, I'm trying to find out here and it's not here. Which of the tables is bigger? Where will it make sense to do it? Desired is less, listings is more. So desired is a smaller table. So why don't I make that the master? Right? So you think that way. And you will say, how do I go and see? How long does it take? Select count from table, select count from table will tell you the number of records in both tables. You don't have to count manually. Select count from the first table, select count from the second table, will tell you which table is bigger, which is smaller. Make your decision. Okay. Now, it doesn't mean the right and the left, all that the right and the left means is which table is the major table, nothing else. There is no other difference in their logic. I could have written the left outer join. I could have just interchanged these two tables here, right itself, and job listings would have become the major table. So the word right and left is not important. The important is which table do you want to make your starting or the major table. Whether you use left outer join, whether you use right outer join, all the differences is between where you are placing your table names, right? So I can't say right outer join is efficient or left. It depends upon which table are you making your major table. So now if I do it, they should all work. So the last last answers are the right ones. So if it is not interrupted, that's the last one, but that was before it. That was before with the nulls, and that's the answer before. So the answers are the same. They are the same. They have to, like as I said, they work the same way. But choice of the master table is important. Just the word right or left is not important. The choice of the master table is important. As I said, I can write the same query using just doing it. So it's not less, the right outer join is not less efficient just because it is a right outer join. Less efficient because the major table or the master table, whatever, however you want to do it, there's no terms for it. It's just my own terms. The master table is the job desired one. We should have taken job desired to be the master table. This is the master table. So when you start answering queries using outer joins, be careful about efficiency, because I will always say efficient code. Okay, that will make you think, otherwise you won't even think about it. Now, just before I leave, let's do this one. Oh, we have for 20 minutes. Oh, I thought it was 50. My mistake. Oh, no, I'm not leaving anywhere soon. Okay. Okay. Before I leave this script, okay, let me show you something else also. Just because I was mentioning it, I want to do it for you. We had done a left outer join here, right? I'm just going to pick it up, okay? I'm just going to pick this up again. And I want to show you something else. No, my mistake. Okay, forget it. No, not on this one. I'll show you a subquery. That definitely I want to show you. Before I move to the next script, okay, guys? We're not going anywhere. Okay, what is a subquery now? So, when did you come to school? 8? So did I. When do you come to school tomorrow again? I do too. When do you leave tomorrow?
Today, 7.
Today 7, no 8, right? Classes don't start at 7.
No, like leaving.
Leaving.
7.
Oh, you're leaving at 7 today? Oh, poor guys. Okay, I'll let you go 10 minutes early. Okay, let me do one more. Last one. Let me just complete this last one. I won't start a new script, okay? I'll leave right away. Okay, what is the subquery? But I come back early again tomorrow, yeah? From 8 to 4.
Tomorrow we are leaving at 7.
Okay, I'll give you a 10-minute off today. Okay, let's write the subquery. What is a subquery? A subquery means a query inside a query. And you will find it easy. You'll say, oh, that's much easier. I don't want to do joins at all. But again, there is a difference between the efficiency, and you read it up yourself, because it's not something that I can explain logically, but engines work differently, and that's what I have read. But again, different for different queries. Now let's do it. This is an easy one. Last one. Okay, select. You want to select the title from the table called job desired. I know it's a big thing. You're doing quite a heavy stuff today. I know, I understand. Right? Okay, so you're selecting the title from job desired. Now you only want to pick up those records where the title is in. Remember your in verb? Do you remember in? We did it with or. If this is or we gave a list in that set. Where your title is in this subquery. Definitely the subquery is easier in this one. Okay, now how is a subquery different? What is a subquery? A query inside a query. There is a select inside a select. Now this select could have been here also as a field also for your information. That's also a subquery. Wherever you have a select inside select, it's a subquery. Okay. Okay, now what? What does it do? It works this way. And they're independent. See, it is an independent subquery. I could pick this up and run it. I can run the inner query as an independent subquery. It's an independent. There is something called correlated subquery. So therefore, I'm mentioning that this is an independent subquery. We'll come to that somewhere a week after. Okay, right? So this gives me all that is in the job listings, all titles. Now what do? I pick up the title from the job desired table if the title is in this table. I only pick it up. If it is not in this table, am I right? Yes. Then otherwise I don't pick it up. So let's try it. So I should have, oh, now the distinct thing. Let me think, will distinct work? Yeah, okay, yeah. There, right? So pick up the title, are you in that? Oh, it's in the listing. Pick up the title, are you in that? Yes, it is. Sales manager, I'm not in that. Chef, I'm not in that. So it's giving a double, all you have to do is put distinct in front of it. Because there were two people who were desiring it. If there is one, then it doesn't matter. So just don't make distinct a habit. Oh, I'll put it everywhere. You have to think whether you need it or not. Okay. Sometimes I may say I want to see it. Sometimes the count will matter. So just don't put it. Think, oh, do I need it or not in my particular query? That's a subquery. Much simpler than outer join. Right? It is. But that doesn't mean you don't learn. You don't have to learn outer join. They have to be learned. And subqueries are basically two queries. It does the inner query, one job. Takes its results, does the outer query, plugs in the results. So it takes more time. Right? Now, there is no argument one way or the other about what's efficient, what's not inefficient, and so on. And I did some reading when I did it for the first time because, like, I haven't worked in the industry, database industry, like a programmer or even as a manager, or nothing. So if you work in the industry, you kind of learn with experience. But I haven't, so I had to read it up because I thought, oh, that's much easier. Why don't I just do subqueries? Why are we even learning how to do, or why am I even teaching how to do outer joins? Sometimes you can write an answer in a query. That's okay. That's different. But otherwise also you have to understand what happens in a subquery and what happens in a join. As you have to understand what happens in a major table and what happens in a minor table. So the reading is up to you. Right? I'll teach you everything. But what is more efficient? If I know it, I'll mention it. But if I can't, I won't make guesses. But a subquery says do the subquery, and this is how it works. It kind of works from in to out. So the inner query is done first. Its results are plugged into the outer query, and that's how it works. Therefore, they're independent. I could run the inner one completely independently by just selecting it, and I was able to run it. But I can't run the outer one without the inner, because it's dependent upon the inner, right? So that's a subquery. So that's your introduction to inner join, outer joins, and subqueries. An introduction. Now our job for the rest of the weeks will be to do more and more and more, because that's how you will become efficient. So I know it's kind of a little, and it is hard work. It is. It's different. I found it difficult when I did it, but this is your best friend. This was not so tough in the sense of, oh, 4 tables, not many fields, and it kind of made sense. But when you're working on something for the first time, it will not always make sense. And what will help you? The ERD. So I'll do one more class with you, 1 week more with you, and then I'll give you the assignment. You may not have done everything in the assignment when I give it to you, but you'll start working. Okay, so your first job will be to make an ERD, and then take a copy of the ERD. Of course, I'll ask for the ERD with label and everything, and then you will start. Usually I do that assignment in groups. I allow two people to work in a group just because it's a little more tough. It's just tough. But if you want to work independently, let me know. But I stick to groups, then it's just easier. People don't come to me, they talk to each other and try to take care of it. Okay, I'll put this on Blackboard. Did I say I would let you go? You're all ready to go, right? I didn't promise anything. You have a class at 4, you have an hour break. So let me put this on Blackboard for you. Go through it, and if there are any questions, you come back and ask me, okay?